Okay, good evening, everyone. Welcome to O-Level Physics. My name is Mr. Chu. Okay, today is Tuesday, the 10th of January, and welcome to the first lesson for the year. Okay, so for this month, we will have 3 lessons. So one week there will be Chinese New Year lah. So that week there will be no lesson. Okay, so for this month, there'll be 3 lessons. We'll be covering this topic called the electromagnetic spectrum. Okay. Yeah, so I'll be covering the theory for today. And the next 2 lessons, we'll go through practice. So I'll take some practice questions from past year paper to practice for all of you. Okay, so I understand that I understand that Han Zhen, you're doing combined physics, whereas for Wang Kang, you're doing pure physics. And let me share with you all the good news is that this topic is both tested in physics. Okay, so let me start with a mind map of the whole syllabus. Okay. Okay, can you all see this mind map? Okay, so in Sec 3, okay, you all should have covered the blue part, the green part, and the yellow part. Okay, maybe you all can give me feedback. Have you all finished all these 3 topics? Okay, majority of them. Or maybe you all can tell me in your in the chat, which topic is your school teaching you now? Okay, last week and this week. So can you give me tell me which topic both of you are learning now? Okay, Han Zhen is on sound. Okay, Wang Kang is on thermal properties of matter. Okay, so if we look at this mind map, so Han Zhen, you're not on sound. Okay, so for me, I'm actually wanted to start off this topic here. So for this year, if you are with me, okay, you'll be going through from EM spectrum to sound, to static electricity, and also on. So we've been covering from EM spectrum all the way to electromagnetic induction. So those topics that is not covered in the combined science, I will let you know if you continue with me lah. Okay, then for Wang Kang, you are at thermal property of metals, right? Okay, so do you have your school touch on with these red topics here? Have your school covered any of the red topics here? So the school have finished all the red topics? Okay, so what your school has done is they covered the blue topic, the green topic, the red topic, and then now doing the yellow topic. Am I right to say that? Okay, for Han Zhen haven't studied light. Okay, so basically for now, I will just, this month, we'll do this topic first. Okay, and we'll see what kind of student we have and look at what kind of topics your school are doing. Then we will make customize to your school. If most of you have not covered, let's say light, I will reverse to light, for example. But for now, I will cover this topic first, then sound and move on. Is that okay? Unless any of the topic before this, you have a big problem, you want me to go through in detail, please let me know. Okay, so the scheme, the schedule will be from EM spectrum. Then we go forward. Any topic before this, light, wave, and all the yellow, green, and blue topic, if you need special mention, please let me know. Okay, we have a new student that come in. Hello, Wenxian, can you please on your camera? Okay, hello, Wenxian, if you can hear me, please on your camera. Okay, hello, Wenxian. Wenxian, can you please tell us which school are you from? Are you taking O level or N
Uh,
level?
I'm I'm from Nanhua. I'm
Okay.
taking O levels this year.
Okay. So you're doing pure physics, ah?
Yes.
好的。Okay, can you also tell me which topic your okay before that, how did you do last year?
I passed.
So what, C6, C5?
Yeah, around there I think.
Alamak, you forgot lah. Okay, then can you tell me which topic your school is teaching you now? Currently, what topic your teacher is teaching you now? Yes,
Um, Transfer of thermal energy.
transfer of, okay. Okay, so let me go back to, okay, now we are now at the, okay, we are now at this mind map. Okay, so for me, I'm going to, okay, for Wenxian, you are now at here, am I right? So can I say that your school have finished all the blue, finished all the green? This one done, kinetic model. So now doing this. Then temperature and thermal property haven't touched.
Temperature finished already.
Then thermal property of metals, no idea, cannot remember.
No.
Then wave, have you all finished everything about wave?
Waste. Waste finished already.
Okay, so your school teach you wave first, then go thermal. Okay, as I
Yes.
was telling your other two friends, okay, you're also here for trial, right? You want to see whether is it useful for you, am I right?
Yeah.
Okay, so what we're going to do this month is we're going to cover EM spectrum, and we are going to move forward. Next month will be on sound, then static electricity, and so on, all the way to the end. So this will be what I'm going to cover, okay, from today onwards. Okay, if you stay with me. Then, if you have any special requests, if a few of you think that, oh, I'm very poor at transfer of thermal energy, okay, I do not know what is radiation and so on, tell me, then I'll customize and then I'll cover those topics that is before this. Is that okay? Okay, so we'll start with EM spectrum. So bear with me. Have all three of you learned EM spectrum already? Yes, okay. Okay, so this is the mind map of the whole physics syllabus. Okay, for combined science, there'll be like one or two topics that's not there. For example, combined science will not have electromagnetic induction. Okay, combined science may not have pressure and so on. Okay, but physics more or less is the same. It's just that the question will be easier for combined science. Okay, so let me go and show you.
I mean, all the chapters and topics like for combined science is actually like same as the wait, combined physics is same as the pure physics.
Yes. Okay, I can show you the difference lah. Okay, but let me share with you. Okay, let me show you the difference between combined and pure. All right. So let me share with you something. The syllabus. Okay, so this is the syllabus. Okay, this is the syllabus for pure physics. Okay, so for pure physics, as you can see, okay, you're going to learn the property of electromagnetic wave. You're going to learn what are the application of the electromagnetic wave, as well as the effect of electromagnetic wave on cell and tissue. Okay, so for combined science, okay, combined science, let me take a look. Okay, the difference is that for combined science, you will not need to know the effects of electromagnetic wave. Is that okay? Okay, so for all of you, you need to know A, B, and C. Okay, and then D is something that okay, D, Hansen, you do not need to know. Okay, but for all of you, you need to know A, B, and C. And this is I don't know, is it a good topic to start this year? Okay, for electromagnetic spectrum, among all the physics topic, this is the driest and the hardest to remember. Okay, so are you able to memorize all these waves in order? Yes or no? Okay, so I see Wenxian very happy, right? How you memorize? What is this? Okay, what song do you all learn? Do you all know that the song is actually by my friend?
It's like by Wong Yan or something. My physics my physics teacher teach me to sing that song, so I remember all the waves in order.
Okay, that song actually is my classmate, made by my classmate. Later I'll show you all the song. So you all know the song, actually this topic is actually become very easy. Okay, but let me start off this topic. Okay, giving you all the concept first. Okay, okay, who know the song so far? Han Zhen have learned the song. Who else? Wang Kang and Wen Xuan, do you all know the song? Yes or no? Have you heard the song
I
before?
don't remember the song. I just remember the alphabet, the first alphabet.
Okay, later you can share with all of us how you remember the order. Okay, but before I continue, so let me share with you a few things first. Okay, okay, so basically for all of you, you need to know the property and application. Okay, A, B, and C, you need to know. Okay, so I'm going to share with you some of the concept, okay, and revise the general wave theory with all of you first. Okay, if anything that you don't understand, please tell me. I will try to explain to you. Okay, let me on my whiteboard. Where is my whiteboard? Yeah, okay. Okay, so for a start, before you learn this topic, okay, in the previous topic, under the general wave theory, okay, can you tell me what is the general wave theory formula? What is the general wave formula? Who remembers the formula?
V equals F lambda, I think.
Okay, very good. Okay, so for this topic, I'm going to cover this formula and I'm going to explain this to you all. Okay, so first of all, let me on my pen. Okay, all of you, can you all remember this formula? V equal to F lambda. How many of you do not know this formula at all? Okay, very confused one. Want me to explain this right from the start? Any of you need me to explain this formula? What does V stands for, Hansen?
Velocity. Wait.
Okay, very good. Well done. What does F stands for?
Frequency.
Okay, and what does the lambda stands for?
Wavelength, is it?
Yes. Okay, so this is the general wave formula, and this is what you need to know. Okay, then for this topic, we call this the electromagnetic spectrum. Okay, it's a range of wave that all will travel at the same speed, okay, in vacuum. You understand what I'm saying? It's a range of wave that will all travel at the same velocity in vacuum. And this, so what does this mean? I'm trying to tell you that this velocity is fixed. It doesn't change. So in vacuum, they travel at the speed of light. Understand so far? Are you all okay with this? Or you already know this? Okay, so for velocity, okay, for electromagnetic spectrum, that the thing I'm going to share with you, it actually all travel at the same speed in vacuum at the speed of light. Clear so far? Understand so far? Okay, so this spectrum goes from left to right. Okay, right in the middle is visible light. Understand? So from left to right, all of them will all move at the same speed of light. So for example, okay, the sun, okay, emit visible light, okay, and then the light travel from the sun to earth to our eye. Okay, it will travel at the speed of light. Are you all aware of that? Okay, the sun also emit infrared radiation, okay, in the form of heat, okay, heat radiation. So it's also traveling in the same speed, at the speed of light. Okay, so this electromagnetic spectrum will travel all the way from radio wave all the way to gamma wave, gamma ray at the fixed velocity. Okay, why am I emphasizing on this? Is because when this is fixed, when your V is fixed, what happened to your frequency and wavelength? If frequency go up, wavelength have to come down. Clear? Then when frequency is low, your wavelength have to be high. So this is the concept that I want you all to understand. Okay, then this is the only concept you all need to understand for this topic. The rest of the thing have to memorize. Can? Okay, if you are okay, give me a yes reaction. If you are confused, give me a no reaction. Okay, thank you, Wen Xian. Wang Kang and Han Zhen, are you okay? Okay, so how many of you are able to memorize the spectrum from one end to the other end? If you can, say yes in your give me a yes reaction. If you have problem memorizing, give me a no reaction. Hey, Wen Xian, can you on your camera? Okay, for Wang Kang, are you okay with the order of the spectrum?
Kind of.
Okay, so maybe Wen Xian, you mentioned that your school teach you how to memorize using the what? By the letter. Maybe you can share with us what did your school teach you?
No, actually, I just memorize it.
Just memorize. How you memorize? Maybe you can tell me your method. Tell us your method.
I just memorize. There's no method.
Just memorize. Okay, then how about Wang Kang? How did your school teacher teach you how to remember?
Well, just memorize.
Same thing, just memorize. Okay, I think Han Zhen got the best teacher. Han Zhen, you listen to a song, right? Is it the radio wave, microwave, that song? Is it the same song or is it a different song? Hello, Han Zhen. Okay, I will play this song a lot later on, but let me just write down the order. Okay, so the first one is radio wave, then microwave, radio wave, microwave, then infrared radiation, then visible light, ultraviolet, X-ray, gamma ray. Han Zhen, is it the same song? Later we sing together. Can. Okay, so for Wen Xuan and Wang Kang, both of you memorize this. You have no method of remembering. Am I right to say that? Am I right to say that? You all just memorize this order.
Yeah.
Okay.
Yeah.
Later I will give you a method to memorize the order. If you think that's helpful, because I still remember this song up to today. The song was created 15 years ago by my classmate. And then now today, I still remember in my heart. Okay, so visible light. Okay, in primary school or even in kindergarten, okay, you all learn about visible light. Visible light starts from red to violet. Can you all memorize the visible light spectrum? Red, orange, yellow, okay, green, blue, indigo, violet. Okay, do you all actually memorize? Can you all memorize this when you are in primary school or even in kindergarten? Okay, this is the color of the rainbow. Okay, this is the 7 colors of the visible light. So if you can see down here, okay, from this spectrum, you notice that the one end is red. So the red will be near the infrared. So can you see these red are similar? Likewise, ultraviolet and violet, they have the same violet name inside, right? Okay, so the end of the light that ends with violet, the next part of the spectrum will be ultraviolet. Just that ultraviolet cannot be seen by our eyes. Okay, likewise, the other end of the visible light is red. Okay, the part of the starting of the rainbow is red. So when you go further down in this direction, you'll be infrared. Okay, so the both of these are red, and both of these has just that the difference between infrared and red is that infrared can't be seen by our eyes, whereas red to violet can be seen by our eyes. Clear so far? So first of all, if you all have memorized the colors of the rainbow, you will know that the spectrum before and after that will be based on the first and the last color. Okay, so the one beside red will be infrared. The one beside violet will be ultraviolet. This one, is it helpful for you all so far? Have you learned this before? Okay, so that's one thing. Okay, number two. Okay, so now I just assume that you memorize radio wave all the way to gamma ray. So can you all tell me, left side is more dangerous or right side is more dangerous? Just
Right
based
side.
on your understanding. Is the left side more dangerous or the right side more dangerous?
Right side.
Okay, well done, Wang Kang. Okay, so as you can see, remember I told you we first talked about the general wave formula, V equal to F lambda. So all of them will travel at the same speed of light. Okay, all of them will travel at the same speed of light. Okay, the only thing that are different throughout of them is their frequency and wavelength. If they have high frequency, they have low wavelength. If they have low frequency, they have high wavelength. Okay, so frequency means how many times it oscillates in 1 second. Is that clear? Okay, so let me ask you a question. Which one is more dangerous? You all tell me on the right side when X-ray, UV, and gamma is more dangerous. So do you all agree that on the right side, the frequency is higher?
Yes.
Okay, so that's how you all need to understand. So this is the only part that you need to understand for this topic. The rest you need to just memorize that. Okay, so on the right side, the frequency is higher, but because the speed is the same for all of them, if the frequency is higher, the wavelength, you know, each wave is actually very small, the wavelength is low. Can? So that is the concept that I want you all to understand. Clear? Then on the left side, because radio wave is all over us, it doesn't do any harm to us, so the frequency is low. Okay, so when it actually travels through us, it doesn't actually go, the things that carry the wave doesn't move up and down so much. Okay, so the frequency is low, it doesn't damage our cell. Whereas for X-ray and gamma, it actually vibrate very, 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 very fast. Okay, so the frequency is very high. So when it goes through our body, it may damage our cell. Okay, so the dangerous part will have a high frequency because it vibrates very, very fast. Okay, did I make myself clear? Okay, so on the left side, it is less dangerous. Okay, if it's less dangerous, the frequency will be low. And then if the frequency is low and they all have the same velocity, the wavelength will be high on the left side. Okay, so this is the only concept I will want you all to understand for this topic. So did I help you all to understand, okay, how does the frequency and the wavelength differ throughout the spectrum? Is it helpful? Or you already know? If you already know, tell me you already know. If you think you have learned something today, tell me you learned something today. Huh? Hello, say something now. Write down in the chat. Type in the chat. Give me some feedback. You all learn something today, or you all, wow. So your teacher is teaching you well, lah. Then why do you not do well? You're actually doing quite okay, right? Just that you're not doing pure. Okay, how about for okay, so now you understand the concept, okay? You understand the concept. Red goes with red, violet goes with violet. All of them travel at the same speed of light. Okay, the speed of light is called c. Is actually 3 × 10⁸ meters per second. So all of you must know that. Okay, all of them travel at the speed of light in vacuum. And because gamma and X-ray is more dangerous, the frequency is higher. Okay, and then the wavelength is much shorter. Okay, why must it be short? Because this times this must give the same C. Okay, so therefore the wavelength is very short. On the other hand, radio wave is not as dangerous compared to gamma, so the frequency is lower, it doesn't vibrate as high, so it's not harmful to our body, so the frequency is low. Okay, and because they all have the same velocity, if the frequency is low, the wavelength will be very long. Okay, so radio wave have very long wavelength, can be up to 1 kilometer. So one wave is 1 kilometer long. Okay, can you imagine? Okay, so this is the concept, the only concept I want you all to understand clearly. Okay, then the rest of the thing you need to memorize. Okay, usually for physics, there's very little memorization. It's all about concept. Alright, for this topic, because there are 7 spectrum that you all need to remember, so I'm going to introduce the song to you. But before I go into the song, any question for me? Okay, no question from Hanzhen. How about the rest of you? Okay, Wang Kang and okay, the rest of no question. Okay, let me just go through the notes very quickly. Okay, so all of you, okay, so there's one more thing I forgot to mention. Electromagnetic wave, okay, all electromagnetic wave, they are all transverse wave. Okay, wait. You are all looking at a different thing. Okay, sorry. Let me change. Change. Okay, so this is a syllabus. So all of you need to know A, B, and C lah. Except for Hanzhen, no need to do D. Okay, so all electromagnetic wave, you must know that number 1, they are all transverse wave. Okay, number 2, they are all moving at the same speed in vacuum. Okay, and this speed is C equal to 3 times 10 to the power 8 meter per second.
Can I ask a question? Like,
Yes.
if they don't travel in vacuum, are they still in the same speed?
Let me think first. Refraction. Okay, if you are not in vacuum itself, okay, their speed can be slowed down. Depends on which part of the spectrum they are. Okay, but in vacuum, for now, all of you need to know is that they all travel in the same speed in vacuum. That's the main thing you need to know. And then this magnitude, okay, number 3 that you need to know is that this value, 3 times 10 to the power 8 meter per second. Can? Okay, so when all these electromagnetic spectrum is not moving in vacuum, okay, then you will learn that in light. For example, light actually, remember just now I told you, light actually is from red to violet. Okay, they will actually be refracted differently. They also will be moving at slightly different speed. Okay, so you're asking me a very good question. So when not in vacuum, they are all bend or reflect differently. But that is why you see rainbow. Okay, if they don't bend, they don't change the speed, okay, then you will not see rainbow at all. Okay? Okay, so there are 7 components. So you need to describe the main components. So there are 7 of them. Okay, as you can see, there's 1, 2, 3, 4, 5, 6, 7. Okay, as you go down, the frequency go up. Okay, as you go up, the wavelength goes up. Is that clear? Okay, so you need to know what are the 7 components. Okay, radio wave all the way to gamma ray. And you also need to know the example of each. Okay, so this will be taught in the song. Okay, so radio wave will be used for radio and TV communication. Okay, then for example, those in the past, now we are all using digital TV, right? Okay, so now the digital TV don't use the radio wave anymore. Okay, but for our radio, you all listen to 933 or 98.7 or class 95, right? They're still using the radio wave. Is that clear? If you have the normal radio that can tune to the frequency. Okay, then microwave a bit stronger. You use it in microwave oven as well as satellite TV. So those are long distance TV, you use microwave. Then infrared, okay, we all know that it's used in our remote control or used in those kind of intruder alarm. Where you have, if you all seen those kind of a movie where you use the infrared camera, you can see all the red color line, right? So that is for infrared. Okay, where if you break the line, you sound off the alarm. Okay, then visible light. Of course, visible light help us to see. Okay, but in a practical way, we use visible light for optical fiber. Okay, optical fiber, you learn that in light. Okay, when we use visible light to transmit information, okay, using optical fiber, you actually lose very little thing. Okay, then as it goes down, you realize that I become more and more dangerous. For example, you're out in the sun, there's a lot of UV ray out there. You are out in the sun too long, you'll get sunburn. Okay, so this is actually a more and more dangerous thing. Okay, so some of us actually use UV light to sterilize maybe medical equipment. And some people don't like to go and suntan themselves, right? They go to the sunbed, go inside for 10 minutes and they get themselves tan. Okay, so as it goes down, it becomes more dangerous. X-ray, as you know, when you go to hospital, we take X-ray, we can't get exposed too long. Okay, and when someone is taking an X-ray, we all need to be outside the room. Okay, so X-ray is getting more and more dangerous. And then gamma ray is the most powerful. Okay, you can actually, exposure to gamma ray can actually alter your genes, okay, your DNA, and that is can give you a lot of problem. Is that clear? Okay, so for all of you, you need to know A, B, and C. Okay, except for Hanzhen, you don't need to know D lah. Basically for D, if we were to absorb electromagnetic wave, right, you have this kind of effect called heating, ionization, or even damage to our living cell tissue. Okay, for this one, those taking pure physics will need to know. Okay, but if not, all of you need to know up to C. Okay, so far? Okay, so let me go through the notes. Have you all seen the notes that's sent to you all? Yes or no? Hello? Why got no response one? Okay, so basically, let me just repeat again. As you can see, from left to right, okay, from left to right, the wavelength, okay, is further apart. Okay, however, the frequency is smaller. So as it goes from left to right, okay, the frequency actually vibrates more in 1 second. So on the right side, okay, on the right side, okay, on the right side, the frequency is very high. So can you see here, radio wave, microwave, infrared. Then actually you can see this spectrum is a very big spectrum. And visible light actually takes up a very, very small part of the whole spectrum. Can you see here? Visible light is actually very, very small. So on the part that is near the infrared will be red color. The part that is near the ultraviolet will be violet. Okay, so all these electromagnetic spectrum is all over us. Okay, it depends on how much magnitude there is. Okay, but our eyes can only see a very small part of the whole spectrum. Okay, so can you see how amazing it is? And then in the past, right, people take photography, like infrared photography or UV photography. So the camera film, the film can actually record infrared light or even ultraviolet light. And then for, recently there is COVID. Okay, and they may set up thermal scanner in the airport. Okay, so they actually use infrared scanner to see whether your body is emitting a lot of infrared radiation. Okay, infrared radiation actually is called heat. Understand so far? Okay, so this is actually, from left to right, you must know that radio wave is actually the harmless and gamma ray is the most harmful. So later when I show you all the song, you all can memorize the song. I'll give you all the link. You all can memorize the song. It's very catchy, so you can remember for the next few decades. And then you will know these are the 7 spectrum of the electromagnetic spectrum. Okay, so these are the property of an EM spectrum, electromagnetic spectrum. So I mentioned already, they are all transverse wave. They can travel through vacuum. They don't need any medium to carry them through. Okay, as it moves from the sun to the earth, it is actually transferring energy. So energy can be light energy. Okay, can be thermal energy. Okay, it can also be radiation energy. Is that clear? Then in the vacuum, they all travel at the speed of light. And this is the speed that all of you need to memorize. Okay, 3 × 10⁸ meters per second. Okay, and then you also need to know your general wave formula, V equal to F lambda. Okay, so the speed is fixed, whereas the frequency and the wavelength varies. Okay, so on the radio wave side, frequency is low. On the gamma ray side, the frequency is high. Is that clear? Okay, then when they move from one medium to another medium, okay, so this thing is a phenomenon called refraction. Have you all learned this before? Okay, in the topic of light. Okay, when refraction occurs, the speed and the wavelength will change. Okay, but the frequency don't change. Is that clear? The speed and the wavelength changes, but the frequency doesn't change. Okay, so the law of refraction and refraction occurs. So previously, when you all learn light, you all just use light because light easy to see. But these two laws, okay, apply to the whole spectrum. Just that for light we can see. Okay, but for the rest, we can't see much. Understand so far? And lastly, they also don't carry electric charge. Okay, so these are the property of the electromagnetic spectrum. Okay, so generally these are all the property. Are you able to understand? Okay, understand. No need to memorize. If you understand, there's no need to memorize. Okay, so let me continue. Okay, so once you know the property, okay, the property of okay, so this part is the property of electromagnetic spectrum. You also need to know the component as well as the application. Okay, so basically they're all mainly the same. Okay, and then the last part. Okay, the last part for Hansen, you don't need to really understand, don't need to really know, but just for your learning purpose. Okay. Electromagnetic wave actually ionizing radiation on us, okay, on a living matter like us. So when we have exposure to electromagnetic wave, okay, it can actually damage our cell, okay, our molecules, okay, and it will lead to funny way the cell will actually divide themselves, okay, so they will not divide properly, so it will cause problem. Okay, and it may also cause the cell to grow too much, and that's called cancer. Okay, and then sometimes your baby can be also be deformed. Okay, so when we have, especially on the last three part, when any of the living matter are exposed too much with all this kind of ray, all this kind of radiation, okay, it actually will ionize our molecules and damage our cell. So not so good. Okay, so for infrared heating, okay, our body actually, the temperature of our body will increase when we are actually when we are exposed to infrared radiation. Okay, so whenever we see infrared, we associate infrared radiation with heat. Okay, even though it's not really a heat. Okay, it's basically yeah, it's actually heat, but it's heat that is being transmitted by radiation. Okay, so a few of you are now studying the thermal transfer of the transfer of thermal energy. Am I right? Okay, you all learn about conduction, convection, and radiation. Okay, so infrared radiation is a form of radiation. Is that clear? So there is conduction, convection, and radiation. So when we receive thermal energy by radiation, it is because of this infrared. Clear so far? So did I help you understand this topic better, or there's still no difference? So give me some rating. Okay, one means you did not learn much so far. 10 means you learned a lot so far. Give me a rating so far. How much have you all learned from this topic? Okay, from me about this topic. So type out in the chat. 1, you have learned nothing. 10, you have learned a lot. So give me a scale. How much have I helped you? Hansen, how about you? How much have I helped you? Okay, Hansen, give me rating 1 because she is very good in this topic. Okay, so I do not know, is it a good thing to start off with this topic? But I hope that through me, you realize that I'm trying to help you all understand the concept more than memorizing. Unfortunately, this topic has a lot of things to remember. Okay, so I'm going to show you all the song. Okay, give me a moment. Let me find the song. Okay, y'all, if y'all want, y'all copy and paste this song. Okay, and then y'all go and listen. Then next week we will sing this song. Is that okay? So for the next 2 weeks, we'll be going through past year paper practice, all regarding electromagnetic spectrum. Yeah. So if y'all have able to memorize the order, then things will become much easier. Okay, so let me share. Where's my chat? Okay, those that who are interested. Okay, this is the song that is on my channel. Okay, this channel is by me. So but this song is not by me. This song is by my classmate when we were in NIE. Okay, so
Can you just like play it out here?
Yes, I'll do that. Wait, I sent to the wrong person. Okay, y'all can copy and paste this and then put somewhere. And then I'll let y'all listen to the song a few times. And later you'll realize that why this song is very helpful to help us memorize. Because it's very catchy. But as I were to play this song, I would want you to tell yourself, don't be shy. Okay? If you are shy in the class, it's fine. Okay, later you are going to shower or what, you are going to sing a song. Can? Okay, so let me play the song now. Wait. Wait. It's not working well. Okay, so I'm going to play this song. Enjoy. Okay, here.
The electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. From the TV station to your living room, that is the work of radio waves. Heating food in just seconds, microwaves do that. Heat treatment for illness, take pictures in the dark. They are even in your remote control. Infrared radiation, the electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. Red, orange, yellow, green, blue, indigo, violet. That is the only part of the spectrum that can be seen by us. The suntan on your skin kill bacteria and viruses. used to detect forgery. That is ultraviolet. The electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. See your broken bones and your hidden bombs. That is the work of X-rays. Kill cancer cells and sterilize dangerous gamma rays. Do that. Now we have completed the electromagnetic spectrum. If you still do not understand, then play the song again. The electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays.
Hey, do you all find the song lagging through Zoom?
SK2 Skin Power Cream. Multidimensional foaming from any angle. Powered by Pitera and multifunction.
So do you all find the song lagging? Wait, give me some feedback. Is the song lagging to you all? Hello, hello. Is it lagging? Okay, so do you all agree that the song is actually very catchy and it can help you memorize the order? Do you think it'll be helpful for you all? Okay, how many of okay for okay for Wenxuan and Wang Kang, do you think this song will be helpful to help you memorize the order? Okay, so today I've finished covering this whole topic. Okay, so maybe I'll just play the song 2 or 3 more times. Okay, maybe you can sing the chorus together. Okay, at least you all memorize the chorus. And then we'll end the lesson today with the order of the 7 components of the electromagnetic spectrum. Okay, if you have reached the point where you can memorize radio wave, microwave, infrared, radiation, visible light, ultraviolet, X-ray, gamma rays. So you can memorize this. Okay, I think this topic should be no problem for you. Okay, and the song itself, besides telling you the order of the wave, it also tells you some 1 or 2 application of each wave. Okay, so they'll talk about radio waves from a TV station to your living room. Okay, that is for radio wave. Okay, so the song actually help you memorize the examples of the component itself. Okay, so for now, before I let y'all go, very early, right? Too early already. Y'all want me? Y'all okay with me letting y'all go early? Or y'all will complain to your mother that I let y'all go too early? Normally my lesson is overtime, right? But this topic is very short. Hello. Okay, so for now, are you able to give me the 7 components of the song? Okay, let me just play the song one more time. Okay, then okay, I don't want this then. Okay, then this song also have the karaoke version. Okay, so if you have the karaoke version, without the lyrics, you can actually sing as well. Okay, let's play one or two more time. When you all can tell me the order and the first.
The electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. From the TV station to your living room, that is the work of radio waves. Heating food in just seconds, microwaves do that. Heat treatment for illness, take pictures in the dark. They are even in your remote control. Infrared radiation, the electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. Red, orange, yellow, green, blue, indigo, violet. That is the only part of the spectrum that can be seen by us. The suntan on your skin kill bacteria and viruses. Used to detect forgery, that is ultraviolet. The electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. See your broken bones and your hidden bombs, that is the work of X-rays. Kill cancer cells and sterilize, dangerous gamma rays do that. Now we have completed the electromagnetic spectrum. If you still do not understand, then play the song again. The electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays.
Okay, so I've played the song 2 more times. As homework, can you all go and listen to the song 10 more times? Okay, so I'll give you all some checkout question. Okay, once everybody can answer my question, then I will let you all go. So I will ask some question in the whiteboard. then you all answer me. Okay, so in the chat, can you all please give me some answer? Okay, so first of all, right, wait, okay, so first of all, the most important thing, please list out the seven component of the electromagnetic spectrum. Okay, question number one, list the seven components of the EM spectrum in order.
Wait,
Okay.
does it like always start from radio waves and end with gamma rays?
It can go either way, but the song teach you from starting from radio wave lah. But if you tell me from gamma ray onwards, also not wrong. It's just
Yeah,
like
because oh,
yeah. It's just like saying your rainbow starts from violet to red, also not wrong, man. But we memorize it from red to violet.
also like usually like from radio waves to gamma rays.
It depends on which side you want to start from. So you want to start from gamma ray all the way to radio wave, also not wrong. If you were to go to internet, right, you will see some diagram, starting from gamma ray on the left, then go all the way to radio wave on the right. Yeah, so either direction is not wrong. Okay, what is important is you must get the order correct. Okay, the order is correct. Whether left to right, right to left, the order, you need to get it right. Okay, so can you all type out and then send to the chat? Let me see what are the seven components of the EM spectrum. Everyone? Well done, Wenxuan. Well done, Wang Kang. Hansen, how about you?
Can I just say out because I type very slow.
Okay, you say out now since the
Uh,
rest.
Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, and gamma rays.
Very good. So you all actually memorize now? Is it easier to memorize with the song? Yes or no? Okay, so next question, number two. EM waves are transverse or longitudinal? So type it up. Okay, Hansen, well done. Wang Kang, well done. And Wenxuan, well done. Very good. Okay, you all understand the topic very well. Okay, so in vacuum, do they travel in the same speed? Yes or no? Okay, very good. So what is the speed they travel in vacuum? This topic is actually not hard. The hard part is memorizing the order. Okay, at what speed do they travel? Okay, well done to Han Zhen and Wen Xuan. Okay, Wang Kang, perfect. Okay, if you were with me since chapter 1, right, I always tell the student, or even in my primary school classes, or I always tell my student that in science, in mathematics, quantity is meaningless without its unit. You understand what I mean? So for example, if I tell you my height is 45, does it make sense to you? Okay, my temperature is 100, does it make sense to you? Okay, so all this will not make sense if you do not put a unit to them. So one new thing that I want you to remember is for all quantity, if they have a unit, please leave a unit down. Okay, so for Wenxuan and Han Zhen, can you please rewrite your answer? What is the speed they travel in vacuum?
3 times 10 to the power of 8 meter per second.
Okay, very good. So from now on, for every quantity, Not all quantity got unit lah, okay? But if a quantity has a unit, please write the unit. Okay, most quantity have a unit. So if there's no quantity, write the unit. Wenxuan, it is a meter per second, not kilometer, not what is LM? I don't know what is L. Okay, it's 3 times 10 the power of 8 meter per second. So the answer for this is 3 times 10 the power of 8 meter per second. Okay, so please write down the unit. Okay, very important. Okay, I got not much question for you already. So I think more or less you understand this topic. Okay, last one, the last question. What is the wave formula? Okay,
V equals m lambda.
what is the wave formula? Okay, Wang Kang, your lambda spell wrongly. Later I explain to you how to spell that. How about the rest of you? Okay, Wenxuan, you spell out. Okay, no problem. You can
I
spell
told
out.
you just now because my computer don't have the lambda sign.
Okay, lambda is spelled like that lah. Okay, it's like rule. Okay, so Hansen, you know the formula?
Oh yeah, I told you just now.
Okay, very good. Okay, so our lesson will be slightly shorter. Normally my lesson is just nice on time or slightly longer. Okay, but I've covered everything. Okay, so this will be our lesson. And okay, so our exit question, let me go and give you some exit question. Once you give it to me, then I call your name, you may leave. Okay, how do you like this lesson? Okay, so 1 means poor, 10 means excellent. Okay, I learned okay, how much do I learn today? Okay, same thing, 1 to 10, give me a rating. 3, Mr. Chu explains well. 1 to 10. Number 4. Okay, one thing I learned today. And lastly, question number 5. I will want to return next week. Yes or no? Okay, so just give me some feedback. Okay, give me some feedback about the lesson. If you can tell me how can I improve, let me know whether my voice too loud, too soft, and so on. 1, 2, 3, 4, 5. Okay, Wang Kang, thank you for your feedback. You may leave now. Okay, Hansen, I don't know how can I help you if you already know so much. Okay, Hansen, you may go, or you may just come for one more lesson. Because next week you'll be going through past year question. Then from there you see whether it's helpful.
Oh, like does it like cost money?
Lesson all got cost one ma. You go and check your parents.
Also, this is like a trial.
Child also got right. I'm not sure. I'm just asked to come and teach. Okay, thank you, Wenxian. Okay, so yep, you have nothing for me. You may go. Thank you so much. Hope to see you again. Any question? You can Google me and then ask and look for me. Okay? Bye-bye.